So let's do a quick video on infinite limits or limits at infinity. So this is a workbook I've been using. So previously in my other videos I said you can either do it by graphing or number line, and I do it by number line, because graphing I don't really know how to graph. So here I'll just show you that it works for any of the problems. I solved this one out in another video, and I'm pretty sure I did that one out and that one out. So I'll show you some of these. So let's take a look at D. The limit, limit x approaches 1 from the left side. Okay, so let's just draw our number line, 1. This is the left side. So a number close to 1 from the left would be like 0.9. So really you just need to look at the signs, because you already know it'll be reaching like infinity. So 1 over 0.9 minus 1, 0.9 is smaller than 1, so you'll be 1 over like a negative number, which makes it a negative number, so negative infinity. And that's where we get that answer. Alright, let's look at E. Here, let's do that again. So 1, but this time it has a little plus. That means we're coming from the right side. So let's do 1.1. 1 over 1.1 minus 1. 1.1 minus 1 is still a positive number. So you're left with positive infinity. Okay. Now here, you see there's no little plus or little minus like those. That means you're coming from both sides. And in order for there to be a limit from both sides, that means these values must be equal, which they're not, so the limit does not exist. See, number line. That applies to these as well. We can see, if we want to do G, well, 1 from the left side, 0.9, right? So negative 1, 0.9 minus 1 is a negative number. So negative 1 over a negative number, negative, negative, positive, positive, infinity, bam. Okay, so I think you guys get that. Now, look at this. This one's pretty complex looking, right? But we can actually just use the same thing. Oh no. Yeah, okay. So I'll put M. Where'd it go? There we go. Limit as x approaches negative 2 of this complex, well, not complex, but you know. So let's draw our number line, 2, negative 2. So you're coming from both sides, right? So that means we need to do it from the left and the right. So it's more steps, but it'll be fine. So from the left side, choose a point. We can do negative 2.1. And then from the right, it'll be negative 1.9. Yeah. So just plug that in. Let's start with from the left. Negative 2 from the left. So negative 2.1, right? So negative 2.1 squared plus 2 times negative 2.1 minus 8 all over negative 2.1 squared plus 4. So here I just need to logic this one out a bit. So it's kind of hard to write because I'm looking at my camera. So negative 2.1 squared would give you a positive number, like positive a bit more than 4-ish, right? Like a bit higher than 4. And then minus a smaller number, but then minus 8. So basically, you know it's going to be negative on the top because that 8 is going to make it negative, right? So then this one, so negative 2.1 squared. That's just going to be a positive number. And then because negative times a negative is a positive, and you're adding again, so that's positive, so negative infinity. That's for the left side. So now we need to try it for the right side. So negative 2 coming from the right side, and our function again was x squared plus 2x minus 8 over x squared minus 4. So here we said that we would use negative 1 1.9, so negative 1.9 squared plus 2 times negative 1.9 minus 8 all over negative 1.9 squared minus 4. So negative 1.9 squared is, so 2 squared is 4, so it's a little less than 4, but it's positive, so positive like 4-ish, or like a little less than 4. Then that minus, well, it'll be higher. Well, okay, so we have minus 8, so it'll still be negative regardless. All over, so now we have negative 1.9 squared minus 4. So negative 1.9 squared is a positive, so if 2 times 2 is 4, and negative 1.9 is less than 2, that means negative 1.9 times negative 1.9 would be positive something less than 4. So positive something less than 4 minus 4 would make it a negative number. So negative over negative would be a positive, so positive infinity. So here we saw that from the left side it was negative infinity, and here we saw it's positive infinity. That means going to our original problem of the limit from both sides, and we said that the limit only exists if the values were equal. Positive infinity and negative infinity are not equal, making the limit not exist, so it does not exist, and that's how we get that answer.